Okay, question 6. We've got a water slide. It tells us the height of the water slide. There's a ickle person over there ready to go down the water slide. We're given their mass, 72 kilograms, don't need to change that. We're given the height in meters, do not need to change that. And it tells us gravitational field strength is 10. Calculate this, so we're just going to need our GPE equals mgh. So we just got to multiply all of that stuff together. 5,040 joules. The person comes to rest at the end of the water slide. What happens to the energy as the person comes to rest? So we've got this idea that the gravitational potential energy is going to go to kinetic energy to go down the slide, and then because there's some friction, that will go to thermal energy. So GPE will go to KE. There's friction, this will create heat energy, and our old favourite, the heat energy, will be dissipated into the air. And you can just see how often that comes up in papers. Okay, a person's pushing a box up a slope. So they're pushing that box up that slope. Explain which one of the three distances shown should be used to calculate the work done. Now, if I was calculating the GPE, I'd just want that one. But my work, if they're pushing it up this slope, equals the force times the distance up the slope. They're having to do work all the way along this hypotenuse here. So that's the crucial bit. That's it. So if I wanted the GPE, I'd want this, but I don't want that. I want the work that we've got to do to get it up there. So we can now go to my model answer. So we've got frictions acting along the slope. That's the hypotenuse. So that's the bit that they're having to do work against. They're doing work against friction. Work equals force times distance. So that's our fat, wobbly dinosaurs. And try to use as many equations as you can in the worded ones. So we will need the 6.3 meters. And the last one, calculate the kinetic energy of a tennis ball traveling at 28 meters per second. Your unit is fine. The mass of the tennis ball is 58 grams. Nope. Divide by 1,000 equals 0.058. And now we're ready. Use the equation K equals half mv squared. So we're going to do 0.5 in our calculator multiplied by the mass, 0.058 multiplied by 28 squared. And that is the bit that people mess up. So 28 squared is 784. And that comes to 22.7 joules. I think I've made an error typing it down. One of those is right, one of those is wrong. But when you practice that in your calculator, you'll see where that comes from.